Assalamu alaikum. Hello. Today's lecture is going to be about the relationship between mass, mole, and particles. This is Wasif, and I'm going to let you know that how these three quantities, that is mass, mole, and particles, are related. Right. Before we move on, we need to know what is molar mass and and also the particle. और मोलर मास समझने से पहले हमें ये जानना होगा कि सब्सटेंस किसको कहते हैं. राइट, वी नो दैट कि सब्सटेंस इज अ प्योर फॉर्म ऑफ मैटर. In matter we know that anything that has some mass and occupies some volume, it is a matter. And matter could be substance if it is pure. If the matter is pure, then it is all substance. Alright. The matter could also be a mixture if it is impure. So the impure matter is termed as mixture and the pure matter is termed as substance. The substance could be an element, it could be a compound, it could be ions. And let me tell you that we're not going to discuss mixture over here because we are going to study the molar mass, and the molar mass is always of a substance. Alright, the element contains atoms. The compound could be covalent, or it could be ionic compound. The ions are always ions. That is, ions contains ions, as element contains atoms. The covalent compound contains molecules. That is, the covalent compound is made up of molecules. Similarly, the ionic compound is made up of not molecule but the formula units. We are not going to discuss here that why doesn't an ionic compound contain molecules and ions contain ions. The mass of an atom is called as atomic mass. The mass of a covalent compound, that is the mass of a molecule, is called as molecular mass. The mass of ionic compound, that is made up of formula units, is called as formula mass. Similarly, the mass of ion is called as ionic mass. By ions we mean that chloride ions, similarly sodium ions, and so on. All these, that is atomic mass, molecular mass, these properties, formula mass and ionic mass, are measured in AMU. Right. Now let's see just the examples of these properties, that is atomic mass, that is of an atom. For example, hydrogen is an element, then its mass should be its atomic mass. One atom of hydrogen has a mass of 1.008 AMU. Similarly, the mass of an oxygen atom is 16 AMU. Let's see just the mass of molecules. If we have molecule of hydrogen, that is H2, the mass of hydrogen molecule is 2.016 AMU. In the same way, the mass of oxygen molecule is actually 32 AMU. Let's see the mass of an ionic compound. For example, sodium chloride, NaCl. The mass of sodium chloride is actually 58.5 AMU. Similarly, the mass of MgCl2 can be calculated if we plus the individual atomic masses on this ionic compound. The mass of magnesium chloride is actually 95 AMU. And we can calculate these masses, for example that of magnesium chloride, by summing of all the atomic masses. Let's see an example. For MgCl2, we need the mass of magnesium, that is there is only one atom, and there is nothing, you know that it's one over there. The mass of magnesium is 24. Just multiply it with its number of atoms and plus the mass of all the chlorine atoms. We have 2 chlorine atoms here, and the mass of individual chlorine atom should be 35.5. If we sum of all these, it comes out to be 95 AMU. So this is the mass of magnesium chloride, which is an ionic compound. So this mass is formula mass of magnesium chloride. Similarly, the mass of ions, for example, if we have hydroxyl ions over here, this mass of hydroxyl ions is 17 AMU. That of chloride ion, it also comes out to be 35.5 AMU. Now we have all the atomic masses. We have atomic masses over here, like that of hydrogen. The atomic mass of hydrogen atom is 1.008 AMU. If we just replace this unit 1.008 AMU, this unit is replaced by grams, then we have the molar mass of hydrogen atom. Hydrogen element. If we just replace this 6 AMU from oxygen, we have 16 grams of oxygen, then it is the molar mass of oxygen element. In the same way, for hydrogen molecule, if we have 2.016 grams of hydrogen molecule, then actually we have hydrogen equal to its molar mass. This is the molar mass of hydrogen molecule. In the same way, for oxygen replaced by gram, 32 gram will be the molar mass of oxygen molecule. Similarly, for NaCl, if we replace this unit AMU, 58.5 grams of NaCl, then we have NaCl equal to its molar mass, that is the 58.5 grams of NaCl is actually the molar mass of NaCl. Same way for MgCl2, replacing this AMU, we will have 95 grams, that is the molar mass of MgCl2. Similarly, we can do this for hydroxyl ion. If we have 17 grams of hydroxyl ion, that is the molar mass of hydroxyl ion. Similarly, for chloride ion, 35.5 gram of chloride ion, we have the molar mass of chloride ion over here. So what we just evaluated over here, we just concluded over here, is that if we replace the atomic mass, molecular mass, formula mass, ionic mass units with grams, we will have the molar mass of that substance. That is 1.008 AMU is the mass of one hydrogen atom. If we have 1.008 gram, then it is the molar mass of hydrogen atom. Similarly, if there is 2.016 AMU molecular mass of hydrogen, then 2.016 grams will be the molar mass of hydrogen. Similarly, the formula mass of NaCl is 58.58 AMU, and 58.5 grams will be its molar mass. What we just have to do, we have to replace the AMU with grams. We will be having the molar mass of that substance. Alright, what we have concluded in this lecture is that if atomic mass, molecular mass, formula mass and ionic mass, all these quantities in terms of grams will be the molar mass. Alright, we have done with the molar mass. Let's see what we mean by the term particles. Let's just move on. Alright, let's just begin with the particles. Particles of any substance, again I'm talking about substance. We know the substance is pure. The particles are of elements. The particles can be of compound, and the particles could also be of ion. And we know that the compound could be covalent, and the compound could also be ionic. The element contains atoms, which are the particles of element. The covalent compound is made up of molecules, and these are the particles of a covalent compound. The ionic compound is made up of formula units, and therefore these are the particles of an ionic compound. The ions are made up of ions, and these are the particles of ions. Right, now we are done with the particles also. The particles of elements are atoms, and the particles of covalent compounds are molecules, and the particles of ionic compound are formula units, and the particles of ions are ions. We are done with the particles over here. Let's just move on with the relationship between the mass, mole and particles. So far we are done with the molar mass, and we are done with the particles, and we just need to know the relationship between these three quantities: mass, mole and particles. I'm going to explain this in my next lecture, so please just